Welcome to the Sedona Community Office Hour. So today it's April 1st, and this is office hour for our April. So for people who are in this call, right, I'm sure you're already very familiar with Sedona, but again, let me just reiterate this. First, Sedona is an open source cluster computing engine for processing large-scale geospatial data. And we have our website, sedona.apache.org. We also have our GitHub repository, and there's Apache organization. We have our LinkedIn account. So if you want to get the latest news about Sedona, if you want to know the latest tips about Sedona, make sure you follow us on LinkedIn and also follow us on Twitter as well. We recently start to post lots of Sedona fun fact and tips on our LinkedIn account. So if you're interested, be sure to follow us. So the status of Sedona. So many companies have been using Sedona in production. So I won't repeat the names on the right. Sedona is a project we started in 2015 as a research project out of Arizona State University. It became mature in 2017 and joined the Apache Software Foundation in 2020. It has over 10,000 corporate users. Many companies use Sedona in production. And right now it has over 130 contributors on GitHub. And it has over 2,000 stars on GitHub. And it has over 2 million downloads last month across different platforms that includes PyPy, Maven, and several other platforms. It has over 44 million total downloads overall. And because of that put Sedona among the top 0.3% most downloaded package on PyPy. So many people use Sedona. And here is a Sedona system architecture. Many of you have seen this before. So Sedona basically follows 3 layers. So the first layer is the spatial query processing layer on top. It provides the spatial SQL, Python, Scala, Java, and R API. So you can pick whatever language you're familiar with. And it also integrates with a bunch of developer tools that includes Apache Zeppelin, Tableau, Jupyter, GeoPandas, RStudio, so on and so forth. And by the way, in the past, many of you have been using Sedona in Jupyter, I believe. Recently, we added Zeppelin support in our Docker image. So if you are interested in playing Sedona in SQL environment with a sort of BI dashboard, be sure to try our latest Docker image. It has Zeppelin bundled, so you can give it a try. And our spatial query processing layer also has a bunch of different distributed query algorithms that can handle the query workload. It takes a spatial query as input and a distributed query workload to the machines in the cluster. And there is also a spatial query optimizer that actually understands the query statistics, the data statistics, and automatically determine the best algorithm for this particular query. And there are many queries in Sedona query processing layer. So spatial range query, spatial nearest neighbor query, so on and so forth. And the next layer in Sedona is the distributed spatial dataset layer. It has many cool functions here, but essentially it decides how data is organized in Sedona. So it has a spatial partitioning, spatial indexing, and a spatial serializer. And the bottom layer is the distributed query engine layer. Right now, Sedona runs on top of Apache Spark, Apache Flink, as well as Snowflake. By far, our support on Spark is the most comprehensive one. You can run batch processing on Spark. You can also run stream data processing on Flink, use Sedona. And you can also use Sedona on different Spark environment. So that includes you can run Sedona on Google Cloud, on Microsoft Azure Fabric, You can also run Sedona with Spark on AWS EMR as well as Databricks. And you can also run Sedona on different Feng cloud offering. So right now, I believe there are two major cloud offering of Feng. So one is Confluent, another one is Wavarika, I think. So we recently tried Sedona on both. Turns out Sedona can work on both with some slight modification on Confluent. So which is also quite exciting. Right, so by the way, Sedona have been supporting many spatial data formats that includes shapefile, GeoJSON, Parquet, GeoParquet, WKT, WKB, and also lots of record format include GeoTIFF, HCF, right? So I'm going to introduce a few formats we have in Sedona today, but if you're interested what kind of formats we support so far, go to Sedona website, right? So there are lots of formats supported by Sedona, and also lots of good integration. We can integrate with GeoPandas, Shapely as well in the Python ecosystem. We can also integrate with Rasterization and NumPy that allows you to run raster user-defined function on top of Sedona. So the easiest way to get started with Sedona, of course, it is through our Docker image. Sedona has an official Docker Hub account under the Apache organization. So if you're interested, please log in to the. You can go to Docker Hub and search for Apache Sedona. You'll find the one that is under Apache. Sedona website provides a very detailed tutorial about how can you pull the image and play around with the image. But here is a quick command. You can pull the latest Sedona Docker image, and then you can use Docker run to open a Docker image. So this will give you two things. It will give you a Sedona cluster with one worker machine on your local laptop. Second, it will give you several IDEs, browser-based IDE for you to play with Sedona that includes a Jupyter notebook as well as a Zeppelin notebook interface. So if you're interested, be sure to give it a try and also go to Sedona website to learn how to use it. And the Sedona follows the 3-month release cadence. The last release we made was in March, actually this month. It is Sedona 171. It was released on March 16th. And the release before that was made in December last year. And the other release was made in late August in 2024. So that's 161. Now, since we just released Sedona 171, let's take a look at this release and see what's the exciting features included in the release. So there are lots of exciting features, right? So here is a highlight. So couple interesting thing. In Sedona release 170, we introduced the geostatistic toolbox of Sedona that includes several statistic algorithms. And in Sedona 171, we introduced the SQL interface of those algorithms, which are very useful when you want to use this algorithm in a pure spatial SQL environment or in a SQL CLI. So you can run dbScan, getIsOr for hotspot analysis and outlier detection for GeoStats in SQL. We also improved the performance of k-nearest neighbor join in 171. In particular, if you still remember, Sedona in Sedona release 170, we introduced k-nearest neighbor join support, which is a brand new join operator we ever introduced in the Sedona history. So the issue was that the k-nearest neighbor join, it runs pretty well at a large scale data set, but in some cases that if you have a very small data set, it sort of cannot broadcast that data set. We fixed that problem in this new release. And a couple of other exciting features: STAC catalog reader, also OpenStreetMap PBF Reader. We also provide a spatial partition DataFrame producer for GeoParquet files. And we also add a bunch of new ST functions, as well as new functions to translate Sedona to GeoPandas through GeoArrow. And today we're gonna have a Sedona Sedona committer, Feng Zhang, to talk about the STAC catalog reader to contribute to Sedona. But I'm gonna quickly go through what we have today, what we have other features. So first of all, for GeoStats, right? For GeoStats, as I mentioned, we have 3 algorithms, dbScan. You can call this function, use our SQL interface, st_dbScan. And this will actually help you to cluster the spatial objects based on their spatial proximity. And if you took look at the figure on the left, so this is actually an example of the dbScan output. So you see, as you see here, it tries to cluster objects based on their spatial proximity. And the second function is the getIsOrg. So this calculates the hotspot, statistically significant hotspot for our data. And this is the figure here. So you see there are a bunch of objects, and their color is proportional to their hotness z-score. And the third function is the outlier detector, and you can call it through st_local outlier factor. And the figure down here, it is a visualization of the outlier result. As you see here, so each point comes with a red circle, and the radius of that red circle is proportional to the outlier factor. If this point is very far away from other points, usually it has larger circle. So this is the outlier factor. And the broadcast k-nearest neighbor join. So first of all, what is k-nearest neighbor join? For people who are not familiar with this, so let's assume we have 2 tables. One table is the restaurant table, and another one is the driver table. The restaurant table has the name of the restaurant and location of each restaurant. And we have name of drivers and also location of each driver. A very simple k-nearest neighbor join is, so find me the closest restaurant per driver, or find me the closest driver per restaurant. So to do that in Sedona, you can use this function called STKNN. You can use this as a predicate in your where clause. Sedona will be able to understand this as a join query. So Sedona going to treat this one as a k-nearest neighbor join query and start to execute the query. In this case, if you put the R on the left, the D on the right in the STKN predicate, so this is going to find the nearest driver per restaurant. But if you put the driver side on the left, the restaurant side on the right, so this is going to find you the closest restaurant per driver. So this has been working pretty well in Sedona since release 1.7.0. However, like I mentioned, there are cases that if one of the join set is small, for example, if the table restaurant only has a few records, so usually the best way to do that is through a broadcast join algorithm. So in this case, Sedona 1.7.0 does not well support broadcast join algorithm. So in this release, we added support. So in this case, if the restaurant side is really small, it's gonna get broadcast to the other side of the join, and gonna be sent to each partition of the driver table, and it will do k-nearest neighbor join locally on each partition. So this is like a shortcut for this kind of special situation. Another cool feature we have is the OpenStreetMap PBF Reader. So for folks who have been using OpenStreetMap, I think this is a really, really important feature, and this makes the data onboarding really, really easy. So for people who are not familiar with OpenStreetMap data, so OpenStreetMap released their road network dataset in a format called NWR, NWR road network. The N stands for nodes, W stands for ways, and R stands for relations. So essentially, it comes with three tables. So the node tables indicates all the point of interest of the road network. So usually that's the uh, road segment conjunction. And the weight table, so think of that as the segments in a graph or in a road network graph. And that's another table. And if you look at the example here, right? So the weights table, it describes the relationship from one point to another, one node to another. And the relation, there's a third table called relation table. The relation table describes relations between the rows and nodes. You can easily recover the entire road network through this NWR tables, and you can do lots of cool things on top of that. In Sedona 171, we offer a brand new reader called OSM PBF. Usually the OSM files they are stored in protobuf format, and it comes with three tables. In Sedona, we provide this data source reader called OSM PBF. If you read that, it will give you three tables all at once. It will give you three tables based on three tables, and you can select which one you want to load into Sedona environment. Okay, so this is the OSM reader. Another one is the GeoParquet with load balance partitioning. As you guys probably already know, Sedona has been proudly supported GeoParquet format for about 2 years. In the past, you can use Sedona to read and write GeoParquet files. And if you don't know, Overture Map has been using Sedona for a very long time to generate all their GeoParquet files. And one of the key factors that affects performance of GeoParquet is the spatial partitioning. Because if you have lots of GeoParquet files in the same folder, and you now have a query to query against those files, you want to make sure that the query gonna get pushed down. You can use the debug statistic in GeoParquet file headers to do data skipping, and you can use that to help you accelerate the query filtering for this query predicate, right? So the problem really is how can I make sure the bounding box of each partition is really small, is really tight, really cover the a very small space, so such that the query predicate, the spatial query predicate, only intersect with a very few data files, GeoParquet data files. So in Sedona 170, we actually provide this function called spatial partitioning without duplicates. So that actually expose the spatial partitioning method we have in Sedona. That actually gives you suppose you have a Sedona data frame, right? That gives you a spatial partitioning Sedona data frame. It makes sure two things. First, it makes sure each partition in this data frame has roughly similar amount of records to ensure load balance. Secondly, it also makes sure nearby objects stay in the same partition. Basically, this makes sure the spatial proximity is preserved. So in that case, if you save this Sedona data frame to GeoParquet files, it's gonna give you a whole bunch of GeoParquet files. They all pretty much have similar size, physical storage size, and their spatial bounding box in each file header is really tight. So that way you can easily skip lots of files. All right, let's move on. Another important feature we have in 171 is the GeoArrow support in Sedona DataFrame. So this is to accelerate the GeoPandas conversion in Sedona. For example, if you already have a GeoPandas DataFrame, you can use this function called create spatial DataFrame to create a Sedona DataFrame on top of the GeoPandas DataFrame. It will use our GeoArrow conversion support. And it is based on what we measured, it is at least 2 times faster than before. So this is going to be particularly useful if you happen to have lots of data needs to be converted between Sedona DataFrame and GeoPandas DataFrame. And similarly, you can also as you see from this function, you can also convert a Sedona DataFrame back to a GeoPandas DataFrame. Of course, you need to make sure that Sedona DataFrame is a large data set that is stored across machines in the cluster. So you need to make sure that if you collect that back to a GeoPandas DataFrame, your driver machine of the cluster has enough memory to hold that data set. Otherwise, you're gonna have a out of memory problem with the driver machine. Another interesting feature we have that is active for Sedona raster, that is called faster rasterization. So in Sedona raster support, one common operation you would run into is rasterization. So essentially what it does is it converts a vector geometry, like a polygon, line string, or point, to a raster image. So this is really useful in a couple cases. First, in some case, you want to rasterize geometries such that you can use that to cover another raster image to calculate statistics. So visually, this will be something. The result of rasterization going to be something similar to the image on the left. In this case, we have a polygon like this one, as you see here. So this is the white polygon here. So that was the original geometry. Now we rasterize that to an image, so such that it follows the resolution specified by this image boundary, the height and width. As you can see here, so since we did the rasterization here, you can see this is no longer perfect polygon here. You can see small distort at the edge of the polygon here. And the rasterization operation, the rasterization result can be then used in many cool other functions. For example, statistics. In Sedona raster operability, we have a couple interesting functions that are really, really useful and loved by our users. One of them is the statistics. So what it does is it takes a vector polygon and join that with a raster image, and it then aggregates the pixel values within the polygons. And this process relies on the rasterization function. And in this case, because the rasterization process got improved in 171, so the performance of our RS statistics also get much faster. So if you are interested and also if your use case relies on statistics, please be sure to give it a try. All right, so that's pretty much all from my side. Now let's welcome Sedona committer Feng Zhang to talk about STAC catalog reader he introduced into Sedona. This is another really, really exciting feature we have in Sedona. So let me invite Feng. Feng, you there?
Yeah, hey, Jeff.
Oh, yeah. Please take over.
Sure. Can you allow me to share my screen, please?
Yeah, you should be able to share screen.
I don't see.
Okay, I need to promote you
Yeah.
to the panelist. Okay.
Okay. Yeah, I think my screen. It's different. Here you go. Okay. All right. Can you all see my screen?
Yes.
Okay, awesome. Hi, everyone. My name is Feng. I'm a principal software engineer at Red Robot, and also I'm a committer to Apache Sedona. Today, I'm going to introduce a new feature that we introduced in the latest release, which is the Sedona STAC Reader. This is a pretty exciting feature because we see a lot of people in the Sedona community, also in like geospatial and analytics community. They did a lot of kind of a raster image analysis, and also like they want to do like spatial temporal analysis for for the data that hosted by the STAC catalog servers. The STAC in general, it is a spatial temporal access catalog, which allow people to publish their raster images or past any geospatial data. And also like once you publish your STAC data, people can use a lot of tools provided by STAC community to read the data, to analyze the data, right? So it's a very big community, like a lot of organizations, individuals actually rely on STAC catalog nowadays to do their everyday job. One of the issues we see in the past for people in geospatial domain to use the STAC data is that because there are some data format issue, people used to do a lot of data pre-processing steps, maybe to query the data in the STAC catalog, download them, store them in a cloud storage, do some transformation, and then they can load the data to whatever tool they have, right? So it is not that community is very time consuming, and sometimes it can lead a very bad performance in their query. Gia and I, and also the community has some discussion like why can we just build a reader directly in Apache Sedona that people can very easily read the data directly into Sedona data frames. This is why we initialized this work. As you can see, we in this new release, we support 2 different APIs, DataFrame SQL API that you can very easily load the data by using the same way that you load save the CSV, load Parquet, GeoParquet, the same way, very easy. You just need to provide a URL to the STAC catalog or collections you want to load. And then we also provide like high-level Python API, which you wrap the DataFrame API so that you can, for people familiar with Python, they can also use this feature very easily, right? So I put I put a link here to the documentation for this new STAC reader, so you can use this link to read more information on that. Okay. So this is like this is the schema that you will see once you load the STAC collections into the Sedona data frame. They're very similar to the item schema that the STAC specification described, but what is the most interesting is that you can see a geometry column, which is internally use the Sedona geometry type, which means you can do whatever you want in terms of you using a UDF, using the geometry to do a spatial join, a KNN join, or any like geospatial operations you want to do with the geometry column directly, right? And also down there you can see a set map which give you all the assets link to that items. These include metadata, binary data, satellite image. So any asset this step item include. On the left, you can see, there may be a red bound of your image, maybe a true color image that you can load, or some other satellite data that you can get directly from the link. So if you are working with Robot, we actually have some functions to directly load some of the image into a more easily used format you can process. But in the open source, you can also do that by yourself, right? So this is the schema. So we have a few optimizations for this reader. One is the predicate pushdowns. For example, if your SQL is like this, you query this table and you give a temporal filter between these 2 days, and also you want to only extract the data from that catalog within this bounding box, for example, right? So you can also do you can also use the special ST functions to do that, and the reader will directly push down your filters to the reader itself. So it will be, as you can see in the physical plan. This significantly improved the performance of the query. So you don't have to iterate the whole global range to find that image, or the whole time range, right? So this is one of the optimization. As I said, you can also, once you load the data, you can also do spatial join. As you can see here, you can use ST functions to join your geometry column to other spatial data set. For example, you can have some point data set. You can, just want to say which satellite image actually cover those points, right? So those are pretty convenient way once you load them into your Sedona DataFrame. We also implement a limit pushdown, which means basically, like, for example, some people, they just want to take a very quick look of the data, maybe like 10 rows of data, right? A lot of the readers, they will load all the data set and then, just remove some of filter or get the first maybe the first n rows from this. In our STAC reader implementation, we actually can tell when to push that limit down to the reader, so that if you do limit something directly, it will be very fast for you to just take a peek of the data itself. This is pretty useful because the STAC data actually load lazily the image, in other cases, images. So you don't want to load all the image globally in order to just take a look, right? So this is pretty important feature if you want to try it. So lastly, we have a Python API that very similar to StackPy, which is a very popular tool in the machine learning and data science community to use the STAC. So with this API, like, people don't have to change their code a lot. They just change they just change from using the PyStack into our API, and then you use the same signature of the functions. So it's pretty convenient way for the machine learning and the data science community to use our stack. Yeah. So what's next? So before I go into here, I can show you some. So for example, so here is one example that I want to demonstrate, like how can we use the stack reader with your notebook. As you can see, what I want to do is I want to find or to search the some Centennial image over Las Vegas to find if there's any solar panel in the image. So usually what people do is they go to here, which is the STAC browser, and apply their apply their spatial or temporal filters, and then they find this image, and then they can zoom in, zoom out, or download the image locally, or use a Python API to find that image, and then do some image processing to get whatever information they want from the rest image, right? So with the new reader, sorry, let me move this around. With the new STAC reader, it's very easy. You just read this directly by giving this Earth Search Centennial STAC collection, and then you can run this SQL to basically extract your ROI. I mean the region of interest area from that image and the time range, and then you can do you can basically display them in our map and do some schema change, and finally you can basically use our display image function to show the image on the notebook, which you can see here is exactly the same one as you can search on the STAC browser. So once you have that image, the rest of is very easy, straightforward by using our RS function in Sedona. You can check how many bands in that image you load. What's the width and height? What's the path? The georeference? Everything you can change that. And also you can split them into tiles by using the RS tile function, and then just display those images one by one, and just check the smaller image very easily. It's this function, and then so one of the things I like most is if you want to do some more advanced data processing, you can also do that. One of the thing is this. So we have some kind of machine learning algorithm that you can directly apply to the tiles you just get from the previous DataFrame operation, and then by just using this SQL, you can basically run your machine learning inference algorithm directly on the DataFrame, and then this one is object detection model. This one is a segmentation model, which you can use to find any objects that you want. So in this case, I'm trying to find a black solar panels in here, and then you can see it successfully identify a tile that includes some kind of solar panel in the image. So I think all this is done without any data pre-processing. That's enabled by the new STAC reader. So you can do end-to-end pipeline without any intermediate storage of your data, which is I think it should be very useful for a lot of people. Yeah. Okay. So I will stop here. Any questions so far? All right. Yeah. So I think we want the community to try these new features, the STAC reader first, and then maybe give us some feedback so we can decide what to do next. But here's some of the thoughts I have right now, like what's to add to the STAC reader. Next, one of the features that STAC is so popular is that there's a lot of extensions that people can add on to the STAC if you want to support all the core STAC extension and also some selected stable stack extensions in the next release, and also some stack catalog is private, so they need a API key. I mean, some kind of authentication. So we want to support this as well, so people can load, stack collection from a private stack server. And we
Oh,
also want.
I saw there is a question
Oh, okay.
from Michael. Michael raised hand.
I cannot see that, but let me
Yeah.
check.
Yeah, Michael, please speak up.
Let me check the chart.
Michael, I just enabled you to speak. So if you have a question, you can ask directly.
Or Gia, if you can read it, the question.
No,
Oh, you cannot.
Michael just raised hand. So
Oh,
I don't know the question. All right, let's move on.
yeah, sure. So we want to support more stack versions as the new release coming. Maybe we'll backward support some of the less stable versions. So people, if they debug their data, they can also use that. So this is another feature we want to support, and also we want to support more PyStack compatible functions. You can basically filter on the attribute, filter on extensions, so on and so forth, so people can more easily use the Python API that we provide in here. Yeah, so that's everything I have for today. But if you have any question, you can ask right now, or you can just post in our mailing list or our any other channel you can find. Right. Thanks, everybody.
Cool. Thank you, Feng. Thank you. All right. So as always, Sedona is always calling for help. So Sedona have a couple notable examples, and if you have new example from your side, you're more than welcome to contribute that back to our GitHub repository. And you can also contribute to our documentation website. If you see there is a typo, you can create a PR to fix that. And you can also participate in our release test. We have a voting process for each release. For every release, we first make a release candidate, and the community vote on that and see if there is any obvious bugs or significant performance issue. And if you are interested, please join that on our mailing list. It only happens on our mailing list as a because that's a requirement of the Apache Software Foundation. So please join us on the voting process on our mailing list. So, and most importantly, the Sedona community is also hosting live stream about Sedona success story. So if you're interested in joining us on LinkedIn live stream, so please reach out to me, and we can host some event together on LinkedIn to talk about how you leverage Sedona in your work. And if you want to reach out, so my email is jiayu@apache.org. You can also reach out to me on our Discord channel. You can find our Discord channel on our website. Cool. I think that's all from my side. I'd love to leave some time to the audience here. So if you have any questions, please raise your hand, or you can type your question in the Q&A session of the webinar here. Feel free to raise your hand. I saw there's one question from Dewey. Dewey, please.
Hi, yeah. I have a question. How do I get to the Discord? I think I clicked the button for Discord, but does somebody have to like let me into the Discord?
Yeah, so if you click the button on Discord, it will ask you to submit a form. Later in the form, it asks you to submit the email address, and then it will send you the invite to the email address.
Okay, I must have missed the email. Oh,
Yeah,
I'll try it again.
cool. All right, folks. If you don't have questions, we can stop here. But if you have any later, you always know where to find us. So you can find us on our mailing list, on our GitHub issues. And by the way, we recently also opened a GitHub discussion on our GitHub repository. So if you have questions, you can also post question through GitHub discussion. And of course, also our Discord channel as well. Great. Thank you all for attending the call today, and looking forward to see you again next time. Bye, folks. Oops. Oh, there is one question from Q&A. Can you please bring up the PBF read? Okay. Richard, is this the slides you want? And by the way, you can find more details about our PBF reader on our website, sedona.apache.org. So there are more details there about how to read that and the structure of the tables. Yeah, and I just sent the PBF reader docs to the chat. So if you're interested, you can click that link. All right, folks. So if you have no other questions, you can stop here. Thank you all for attending the call. Bye, guys.